Welcome to Colorful Analysis channel. Today, grab your painter's brush, hit subscribe to be part of our creative canvas, and splash a like as we dive into the vibrant world of deep learning. Let's create a masterpiece together. What is the difference between AI, machine learning, and deep learning? Imagine AI as a smart assistant. Machine learning has its ability to learn tasks without the specific instructions, and deep learning has its brain power, mimicking how our brain works to make a sense of complex information. In essence, AI is a concept, machine learning is a technique, and deep learning is the powerhouse behind it. Let's talk about fundamental of deep learning. Neural network and the layers. Neural networks are like the architects constructing the foundation. These networks are built from artificial neurons, tiny building blocks that work together, much like the interconnected neuron firing in our own brains. Imagine these artificial neurons as the heroes of our story, each one contributing to the grand narrative of machine intelligence. They are the ones that learn, adapt, and evolve, forming the very essence of deep learning. Now, let's dive into the application of this neural magic. It's not just about the raw processing power, it's about the ability to learn and adapt. Neural network become the storyteller, understanding and interpreting data in a way that go beyond the calculations. Layers in deep learning are like chapters in a captivating novel. Each layer adds a new dimension to the story, capturing complex patterns and details as we progress. It's not just about the one layer, it's about the depth of understanding that comes from stacking them together. With each layer, we delve deeper into the complexity of the data. These layers are the storyteller, and recognizing the feature in an image, text, or any other data that may encounter. Before talk about famous deep learning algorithm, would you please subscribe? CNN Convolutional Neural Network specialized in image processing. CNN detect pattern through convolution and pooling layer. CNN find diverse applications in the realm of computer vision, image classification. CNN excel in image categorization, effortlessly assigning image to predefined categories. This capability is harnessed for automatic photo organization on social media platforms, streamlining the process of sorting and managing vast amount of visual content. Object detection in scenarios requiring the identification and localization of multiple objects within an image, CNN shine. This capability proves invaluable in applications like self-scanning in retail, helping identify out-of-stock items and optimize inventory management. Facial recognition. An important application of CNN lies in facial recognition technology embedded in security systems. CNNs efficiently control access based on facial features. This has transformative implications for enhancing security measures and streamlining access control in various industries. The next algorithm is recurrent neural network RNNs, designed for sequence data. RNNs maintain memory for context aware learning. RNN find applications across various fields due to their ability to model sequential and temporal data. Natural language processing or NLP, like a language modeling, predicting the next word in a sentence for tasks like text generation and autocomplete. You may see that in the Word Office. Machine translation, translating sentences between languages using RNN for encoding and decoding. Sentiment analysis analyzes text sentiment by capturing contextual information from word sequence. Another application is a speech recognition and synthesis, a speech to text or text to speech, converting a spoken language into written text, or vice versa, generating human like a speech from text input, enhancing voice assistant and accessibility tools. Time series analysis and forecasting, like financial forecasting, predicting stock prices, currency exchange rate, and other ones. Now, weather prediction, analyzing historical weather data to forecast future weather condition. Another application of RNN is music generation, generating music sequence by learning patterns from existing compositions, facilitating the creation of new musical pieces. Another one would be video analysis and action recognition for video understanding, processing frames in a video sequence to understand action, object, and activities. Gesture recognition, recognizing hand gesture like me, but you cannot see me, and the movement in the videos. Application is sign language translation. LSTM, long short term memory, a type of recurrent neural network designed to address the vanishing gradient problem and capture long-term dependencies. LSTM designed to overcome the vanishing gradient problem of RNNs, incorporate a more complex memory cell structure, enabling them to capture and remember long-range dependencies in sequential data more effectively. LSTM application is more or less like RNN, but due to ability of LSTM to capture and retain long-term dependencies, make them particularly valuable in some special task like sentiment analysis in a long paragraph or documents. Let's talk about the last algorithm in this video, but I will come back with the other algorithms in future videos. An autoencoder is a type of deep learning model, has a two main parts, an encoder and decoder. The encoder compresses the input data in the lower dimensional representation, and the decoder reconstructs the original data from this compressed representation. The goal is to learn a meaningful and efficient representation of the input data. In a deep autoencoder, both the encoder and decoder consist of multiple layers, making it a deep neural network. The use of multiple layers allows the model to learn hierarchical features and complex patterns in the data. The training process involves minimizing the difference between the input data and its reconstructed version, encouraging the model to capture essential features. Some application of autoencoder is like a data compression. Autoencoder are used for compressing data, reducing its dimensionality while returning important features like image compression in application where efficient storage or transmission is critical. Anomaly detection. Autoencoder can learn the normal pattern in the data and detect anomalies or outliers, identifying unusual patterns in network traffic for cybersecurity. Thank you for joining the colorful analysis journey in the part of deep learning. Until the next video, keep the curiosity alive.